So we're going to continue that with our mixed numbers. So I'm going to go ahead and I'm going to represent a whole, and I'm going to use 8 boxes because I know that with the 2 and the 4 that 8 will work. And I'm going to represent the top by showing us 1 1/4. I'm going to shade in that 1 1/4. So my length is 1, and then I'll put the 4th over here. My width, I need to be 2 1/2, so I need another box. And I'm actually going to shade these all in the same because this is still the 1 1/4 coming all the way down, so we need to leave that. So I still only have 2 here, and then I need another half. So I'm going to actually create another section. And I'm going to come all the way down with my 4ths. So the width of my entire area is 1 1/4. I want the length to show 2 1/2. So I'm going to switch colors, and my 2 1/2 does all of this. And then I only want half of this one. And just like with every other model, we're going to look at the part that has both shadings. So I'm going to look at just this outline here. So 1 1/4 times 2 1/2. So this rectangle here. So in this rectangle, I have 1 whole, I have 2, well, it's another 1, but a total of 2. And then I have, this is a 4th, this is a 4th, this is a half, and this is an 1/8. So I have 1/4, 1/4, which is a half. I have this half. So these 4 pieces, or 3 pieces together gives me a whole. So I have a total of 3 wholes and then another 1/8. So my answer is 3 1/8. I can also model this by finding improper fractions. So I can, or before we do improper fractions, sorry, let's actually model this with just the box method. And we're going to do the same thing except for without the picture. To draw the big picture above can become way too cumbersome and confusing, but we can see that it does work. So I actually prefer just to put my pieces in. So I have 1 1/4 here. So this is 1 plus a 4th. I decompose that fraction just like I did up top. And then I'm going to come here, and this is going to be 2 1/2. Just like we did with decimals, just like we did with whole numbers, we're going to put the product of the partial products in each of these parts. So 2 times 1 is 2, and that's where this 2 comes in up top. And then I have 2 times a 4th is 2/4, which is the same as 1/2. And again, that's what we found here, 1/4 and 1/4, or we have that 2/4. So that's 1/2 here. And then I have 1 times a half, which is a half, and that's this section here. And then I have 1/2 times 1/4, which is 1/8, which again is this section in my model. So I have 2, the 2 halves make a whole, which is 3, and then I have an 1/8. So I have 3 1/8. I have used easy numbers, so I didn't have to do any extra work to add these together. However, you might have to come off to the side and do an addition of your 3 boxes if necessary. And the third way that I can do the exact same problem is really a shortcut. There's no modeling involved. It's just another way that we can solve the problem. So we can create improper fractions by taking our 2 1/2 And we know that 2.5 is the same as 4 over 2 plus a half is 5 over 2, or 2 times 2 is 4 plus 1 is 5 over 2. And then we want to multiply that by 1 and 1/4, so we have 4 fourths plus 1/4 is 5 fourths. Or you can also look at that as 4 times 1 is 4 plus 1 is 5. And when multiplying fractions, we know we just multiply the numerators to get 25 and multiply the denominators to give me 8. So I have 25 eighths, which is a division problem. 8 can go into 25 3 times, which is 24, leaving me 1/8 left. Okay, so we're going to look at a couple examples, and I'm not going to ask you to draw this piece out, but you are going to be asked to be able to model it this way as well as with improper fractions and just multiplying with the numbers. So let's do a couple as examples so that you can do some on your own. All right, we're going to do 3 1/5 times 2 2/3. So I'm going to create my box, and it doesn't matter how you set it up because we're not going to draw the picture. So I'm going to decompose my top fraction as to 3 plus 1/5, and then my width is going to be 2 times 2/3. So again, just like all of the other ways that we've multiplied using this model, we're going to do our partial products by doing 3 times 2 is 6. 2 times 1/5 is 2/5. 3 times 2/3 is 6/3. And 1/5 times 2/3 is 2/15. Oops, 2/15. And so now all I need to do is add each of these fractions. So I need to add 2/5, and 6/3 is the same as 2 because 6 divided by 3 is 2. So I don't really need to add that in just yet. I just want to add my 2/5 and my 2/15. I know that we cannot add or subtract fractions until we have a common denominator. So I'm going to make that 15ths because 5 times 3 is 15. So 2 times 3 is 6. And when I add that to 2/15, I get a total of 8/15. And then I have 6 and 2 is 8. When we think about that, our number makes sense because 3 times 2 is 6. And then I have these extras. So I know that it's going to be above 6. And even if I were to round this to 4 and 3, I would get 12. So my range has to be between 6 and 12. And my answer falls within there. So my answer does make sense. But we're going to go ahead and check it with using improper fractions. So 3 1/5 becomes 16/5. Again, we get that by doing 5 times 3 is 15, plus 1 is 16/5. And 2 2/3, 3 times 2 is 6, plus 2 is 8/3. And now we have 16 times 8. So if you don't know how to do that in your head, then you just have to go to the side and do 16 times 8. 8 times 6 is 48. And 8 and 4 is 12. So we get 128 over 15. And then you have to divide. And so I'm going to come down here and divide. And then you have to figure out how many times can 15 go into 128. And using partial products, maybe you don't know, and that's okay, but I know that for sure it's going to go in not 10 times, not 9 times. So I'm going to say I know that it goes in 6 times. Okay, so 6 times 15. I know 15 times 2 is 30. So 30, 60, 90. And I get 38. I know it can go in 2 more times, which gives me 30. And I'm left with 8. So my whole number goes in 8 times, and I have 8 left over, and I out of the 15. So either way you do this, you get the same answer. One of the nice things about both of these ways, I prefer, if I were to solve this, I would have liked this problem better because I could do more in my head with smaller numbers, where you might have to, with improper fractions, you know, do your 16 times 8 and then come do the division. Either way is acceptable, but it's nice to have both so that you can choose which way you prefer. All right, let's look at another one. This time let's do 4 1/5 times 2 2/7. Okay, so again, I'm going to create my box, and I have 4 1/5, so I've decomposed it, and 2 2/7. We're going to multiply. 2 times 4 is 8. 2 times 1/5 is 2/5. 4 times 2/7 is 8/7, and then 1/5 times 2/7 is 2/35. So I know that 8/7 is the same as 1 1/7, so I only want to work with my fractional parts right now. I know my common denominator is going to be 35, so I'm adding all these parts up. And 5 times 7 is 35, so 2 times 7 is 14. 7 times 5 is 35, so 1 times 5 is 5. And this one stays the same because it already has 35. So now I have 14 and 5 is 19, plus 2 is 21 35ths, and I have my 1 whole and my 8, so I have 9 and 21 35ths. Again, that makes sense because I have 4 times 2 is 8 if I round it down, and if I round up, I have 5 times 3, which is 15, so I want my answer to fall between 8 and 15, and it does. So again, if we're going to do the mixed numbers to improper fractions, we're going to end up with a little bit bigger numbers this time. So 4 and 1/5 becomes 21/5. 4 times 5 is 20, plus 1 is 21/5. And 2 2/7, we have 7 times 2 is 14, plus 2 is 16/7. So again, you're going to have to go off to the side and multiply your 21 by 16. Six times 2 is 12, 0, 1, and 2. And you get 336. So I get 336 over 35. And now we have to divide that. So I know that it's not going to go in 10 times because that would be 350. But since I think it goes in 9, I'm going to go ahead and try that. 9 times 5 is 45. 27. So we have 315, so 9 times 35 is 315. If you needed to go off to the side of the paper and do that, that's fine. 6 minus 5 is 1, 3 minus 1 is 2, so I'm left with 21, and there is not anything left over, or I can't go at another whole time, so 21 is what's left over, and that's out of 35. So again, my two answers match, but again, for me personally, and for probably many of you, working with smaller numbers is easier than to work with big numbers and to divide. Either way is completely acceptable, and you can use either throughout your practice. All right, the next one, we're just going to do super quick with the box method because many of you will be using that. Let's do 5 1/5 times 1. And let me change that. Let's do 5 1/3 since I've been using fifths. And we'll do 5 9ths here. So just create your box, decompose, and multiply. 1 times 5 is 5. 1 times 1/3 is 1/3. 5 times 5 9ths is 25 9ths. And 5 9ths times 1/3 is 5 27ths. In order to do this, all we have to do is add up our partial products. I'm going to switch this first so I can see what fractional part is left over. I know that 9 goes into 25 2 times, and that is 18, so that gives me 7 9ths left. So I'm going to add 1/3, 7 9ths, and 5 27ths.